different techniques to remove the criteria polluted from the flue gas, right? This is one of the effective ways, other than this cyclone filter, and there is a gravitational filter also is there. So, which is like a little primitive way to take out the your particulate matter, right? So, particulate matter, and you understand that when it is a very fine particles are there, so the gravity effects are really lesser on that, right? So therefore, for that, you need to employ, one is like your cyclone filter, right? So you are importing us, you are importing a rotational motions to it, right? So therefore, this rotational motion takes care actually to give this energy, kinetic energy lesser, and reduce that, and gravity can act on it, right? And if this is, you can understand, we are here electrostatic precipitator, and it is a completely electric force is taking here, right? So this one is that this particle collection efficiency, right? So this Joyce-Anderson, this equation, so it was derived independently by this Ivan under and later is W. Okay, so together then it is called Joyce-Anderson equation. So let us try to, it is a very good problem actually. You have already done this mass balance equation. So let us try to derive it. It's a not very difficult one. So as an assignment, the difficult part we will do that this cyclone and etc. that other efficiency. And I will give that assignment, that part, and with some problems, those things you can do it as a part of assignment, right? The back rows, these figures are there. Right, so that what is the schematic? Schematic of it, remember. This is your parallel plate collector, right? So parallel plate collector, and then this gas is coming in, right? Coming in it, and you have either grounded, both are actually grounded. This is for the collecting plate. So collected electrode, and in between you have your discharge, right? Which is right? Whereas which is a negatively biased at very high voltage. So therefore, like a 10,000 volts or something like that, and this is when the difference is better, right? So if you have difficulty, it is something like this, right? Got it, right? And so you are looking from top, and your this gas is coming in from here. Now with velocity u, right? So the first part is that this flow is coming in, and after that there will be your discharge will be happening, right? When it is coming in near to this, so it will be discharging. It is forming the coronal discharge. Then after that, the electrons which are there, this is collected by the particles, right? And you understand that electric field will be forming like this, right? So very high electric field there. Right. Similarly, all these things we don't cross, of course. Right. So similarly, this. Okay. So this electric field means that these particles are now, these dust particles are not charged, and after that these dust particles will be attracted because it says 0 and this is negative. So both sides, these dust particles, this is negative, this will be attracted to this. and on this part, they will be experiencing collisions, right? So therefore, they will be acquiring a terminal velocity, right? So this drag force, small particle, you can use the Stokes law. Okay, Stokes law you can use. That's 6 pi eta that's V. Okay, so with the viscosity of this air, and what should be the other force? Other force is? Huh? No, drag force is there. Drag force now, drag force you I said that drag force depends upon this D. But what is it balancing it up? Then the terminal velocity will be acquired. So what is the other force? Viscous force is coming in here. This is sorry, E, right? Yeah, 6 by E. Right. So what I am saying that what should be the what it is? This is your Stokes law and this Stokes force. You can say that. What is the other force? It is balancing it. Right? Like for example, this spherical droplet. What is it? This is gravitational, right? Then the terminal velocity is actually there. So what is the other force here? What is it? क्या इसको खींच रहा है? हाँ? हाँ? तो gravitational force वही तो बताया. Gravitational force is very small on this. The electric force, the electric field is there, right? ना problem में तो आ जाओगे ना. What is going on? So this is the electric field, right? So all these things, इसका direction क्या होगा? Electric field lines का arrow किस साइड होगा? उस साइड क्या होगा? कौन सा पॉजिटिव है कौन सा नेगेटिव है?
इलेक्ट्रोनेगेटिव.
This is positive, this is negative.
Yes, electronegative which we have one negative और ये
ठीक है. So अब ऐसे होगा तो नेगेटिव पार्टिकल्स will come this side, right? इलेक्ट्रिक फोर्स क्या होता है? What is electric force? हाँ किसने बताया? अभी Q in V, right? So means that when actually I am doing the easiest part, that connection efficiency, right? There is multiple things you need to see them. First thing देखो यहाँ से तो आ गया, but this one is अगर 2 micrometer the smaller particles के लिए it's okay, right? Here you can actually see अगर करोगे and you can find out what is the field which will be using as a not D but हमारे केस में W है, we are writing notation as W, right? But if it is a little higher, then you need to use that Stokes law that cannot be applied, right? Okay. Another thing is that what is Q? How much is charge? ऐसा नहीं कि मतलब there is one electron चक्कर बन के उसके ऊपर, so there is a how much depends upon that. So what is this particle क्या flow rate है उसके ऊपर it is like that. How much it will be also charged. That's why on average you need to understand that, right? So now that there is a like when you are that these particles are now collected on both sides, right? So your this going with say some flow velocity is there, which is that flow velocity is there, and this one is say C in, okay, which is the concentrations of your particulate matters, right? That pollutants concentration, right? And then it is when it is going in, then after that it is collected on both sides, right? These both plates it is connected, right? So this is the plate, this is your plate, right? And the plate, say the height is h, and say the distance is between them is d. Okay, so this is collected on both sides uniformly. For your equations purpose, these assumptions you have to make that, right? And that is of course will be maintained there. So it is uniformly collected on both sides, and it is the gas velocity that is maintaining say same, right? Same flow velocity, u uniformly completely playing. If it is u here, it is u here, and here it is u there. And if it is a C in, then C out. So you need to find out what is the C out by C in, or more precisely, collection efficiency 1 minus C out by C in. That's it here, because because that is what is going out, then what is the collection efficiency, right? So that is what you need to find out. Okay. So say that uniform flow, and this W of course it will take some time, but you can just think that this both side, this W which is uniform, it is maintained. That is terminal velocity. Very quickly it is maintained, and you can assumption that it's like maintaining from it. Then there is this, you kind of see that this there is a bending in this electric field, right? Bending. So you have like a lots of electrodes are there. So these electrodes will be there. So more or less what happens that you can consider that this electric field is actually uniform, right? So fully uniform. Right? There is a what is that? This direction. So normal to that, there is a it is constant actually. W is like a constant. No other components are there. So with that, so your collection is collection with the W. So after that, what you can do? This simply the mass balance is equations you can apply here. Of course, differential. So, say there is a section you consider delta x, right? And then in this section, so every like a section there is a this collection is going on, right? So means that say with this section there is a this cx x and this is x plus delta x. So I am going out is x plus delta x, right? Okay, and there is a collection of this, so means that Cx plus delta x or Cx minus q, okay? So that much has been collected, with that much has been collected this, okay? You know which country you are from? You are from India or? Zambia. Okay, okay. So I sometimes what happens, I am speaking English, I hear also forgetting the different here, sorry about that, okay? So I will keep it in mind. Okay, so fine. So now that simple mass balance. So when you did the mass balance, what you did? This mass balance equations, you remember that, right? This CSTR, CMBR, not CSTR actually. So CSTR, when you did that, what was the inlet flow? Inlet flow means that the volumetric rate you need to find out, right? So volumetric rate was your this QC, right? So QC here, QCX, because let us consider a differential this element Cx, right? And the difference is because it has a this cross section is uniform, velocity is set, so therefore volumetric flow rate is also set, right? So therefore Q and this one would be set. Okay. Alright, and what is the difference? That is collected there, right? So which is your this Q and the this you got it, right? So this volume here, remember, so this is the cross section. This is the cross section through which it is going in there. Okay? This, if it is a means that how much is H into D. H into D into that your delta x. Alright, that is the volume with the velocity. That is the volumetric flow rate. Got it? For that collection here it is a this volume. So here that is a longitudinal and that is the your transverse. The collection is in transverse. This is U, this is W. Okay, got it? So I am mentioning it QCx minus QX plus delta x minus that small q is that volumetric flow rate of the collections of the particles on the electrode. This is the volumetric flow rate of its flow through the duct. Okay, the problem is clear, right? There is no trouble in understanding the problems there. What should I write? See here. Right, it's a differential, right? Delta x is very small, right? So here, as any other differential problems, we can make it Right? And take it an average or what is its middle. So x plus x by ultimately we take the difference. Right? dcx will be done there once the problem is set. What is q now? Huh? What should be the q? Q is volumetric flow rate, right? I have the dimensions with me. See the problems, there are several problems will be given like that. You have to construct your, well, numericals also, right? You have to see, identify that from there. So it will be asked that what is the volumetric flow rate? So volumetric flow rate is that, what should be? This is U, right? And H is the height. H is the height. Okay. You make it a this section only, right? This section, because this is one collection, this is one collection, right? This half and this half there. So H into D by 2, which is your area. H into D by 2 is the area of this. This is D by 2. Okay. How much volume goes in per second of the gas? How much? We discussed it in the last class. What?
Velocity?
Yes. U. That's it. H d by 2 into U. Right. So if it is asked what is the volumetric flow rate, H d by 2 into U. D by 2 because I am making a problem how? Because the collection is from here to here and here to here. So we cannot make D now. Better that take this one, this half and this half. Symmetric problem. So not problem, right? Okay. So you know that what is this? Similarly, what should be the small q? Delta x will come now. Okay, so one of these is delta x. So what should be there? That understand that, right? This is your area now. Here, actually, you have to consider here. So what should be?
Delta x divided.
Delta x into d by 2 into w.
Sorry, collection. My bad. The collection is this side. So not this side. My bad. It should be this side. Right? That is how it is collected. My bad. Okay, so it is a H into delta x into. That's it. Done. Right? You write it. Done. It's done. Okay. Already it is done. Okay. So just write this thing. So I am writing the final result. Okay. So this one I have taken as a differential element, and I can take this one as a C, C which is a, of course that function of x, right? Function of x. So therefore we can write u, sorry. And therefore you can write do the integration from if it is a L, that full length. So therefore for x0 to L and C into CL. No. into L is the total area, right? H into L is one plate's area, so 2 into HL is the total area what is there, right? So minus 2 WA DH, DH into this U, that should be, here I made a, I mean you can make it as something else you want, right? Yeah. But that is a total volumetric flow which is given by QDH, right? Okay, got it? Alright? Okay, so if there is a say you have a 5 plates, 1, 2, 3, 4, 5. Okay, 5 plates which has a area of a small a. So you can find out what is the total area, right? Right? So what should it be? Right? So 1, 2, 3, 4, 5, 6, 7, 8. Right? Similarly, if it is like a one duct, what is the volumetric flow rate? Then you have to multiply that total volumetric flow rate and go to repeat. Okay? Right. Now we can go to this next. So I will, as I think Professor Satya also gave some assignment, right? Okay, right. So I will give something, one assignment I can give, and which will explain this similar problems, and later maybe we can do something else. Right. So this one, in fact, actually, with the invent of different these fabrics, actually, right? So this becomes a very effective way for taking out a particular matter. It's the filtering. Okay, filtering, so that your fine particles with the bag house you can collect. Dirty gas goes. So there is like a huge this. I mean, there are a series of these things that are actually there. It's like some cylinders like that, so bag actually. And there's a warm gases there, so it will be going out there. And please understand, it's a fabric actually. Of course, there is a porous, so the gas will come out there. But it is so fine, this particle, that can be actually taken out by these bags. Okay, so they can get a clean gases, and you can see that even like a 1 micrometer or smaller. It can be taken up, right? So one thing, I said that one assumption here, I just remember when I was reading that there is a uniform electric field, right? So what happens that is this dust actually when it is collected, right? So one thing it may have a re-entrainment. Re-entrainment is that this dust from it is collected, it can again come out from from here, and it can again join here, right? So of course these equations we are not, when you are deriving, it is assumed that there is no, or if it is there, it is very negligible. So that's why they do some this rapid voltage actually. So therefore they shake it, and all this comes out, and again start to avoid all these things. Okay. So you can see that these things actually economically little not that much valuable there, but it is still used because it's so effective, large and expensive, and there's some problem may happen that if there is some industrial plant which contains corrosive chemicals, then in that case it may harm this fabric. Right. So we can go to our next section. Air pollution, we can briefly discuss air pollution from the mobile sources. So emission from the motor vehicles, the principle is that your this combustions, and the other part is that there could be from the fuel some evaporation can come out there. And the most of this criteria pollutants are this carbon monoxide, right, which has been almost like a with the different this Clean Air Acts and this motor vehicle acts are there. That has been almost curbed actually, this carbon monoxide, sir. Okay, so there are like, but this HC that actually is there, which comes out, and this NOx is of course the principal criteria pollutants which comes from the motor vehicles. Okay. Right, so improvement of CO and H2 emission made at expense of the increased NOx emission, and please understand this reduced pollution is you can fuel efficiency can be increased there. Your combustion chamber that can be taken care post combustion like a catalytic converter that can be employed, that is employed in fact like that, right? So for taking care of a three-way catalytic converter, right? Yeah, so three-way means actually it can take care of all these things. So therefore this three-way catalytic converter, and of course which is now in fact very actively tried is the use of alternative fuel, right? Alternative fuel including of course your electric vehicles, right? Okay. So alternative fuel is that biofuels are there. So this one I don't think that I need to talk much of it, that this conventional auto cycle which is the 4-stroke engine, and you can see that, right? So there are 4 strokes. The first one is intake strokes, where there is your air fuel that mixture actually comes into the first here valve, and after that that your compression stroke is that this your inlet and outlet both valves are closed, and your this what is that? This crankshaft actually is moving, and therefore you will be compressing it, right? Compressing. So why do you do compression? Because you are like this increasing, right? This temperature there, and both air fuel mixture is compressed by the rising pistons, and there is this for petrol these things you need a spark plug, right? Spark plug is required there, and then after that, as it is this fuel is. This combustion actually takes place there. There is a huge expansion will go there, and therefore you go to these power strokes there, and which increase the temperature, pressure, expansion, combustion, and drives the piston down. And after that, this exhaust valve is open so that your spent gas is out, and this new next cycle you make room for the next cycle, right? So there, one of these, I mean, I am not going all this combustion, this science here, but what is one of the, I mean, in your pollution system, that this air fuel mixture ratio, that is important there. And here, that one of this characteristic, this gasoline has been taken out, and for your full combustion, right? The fully burned actually. When you take this, so this should be your stoichiometric ratio, right? Stoichiometric ratio, and of course, I mean, depending upon that your air, that ratio of the air is nitrogen, then you can add this part, 38.5 because it's 10.25 O2, and for that this much nitrogen is available there. And you can see that CO2 is forming, so that is what, I mean, you try it out that it is a complete, this combustion actually taken care. And from there, when you find it out, that this once you find it out, this 10.25 O2 is required. For that, 38.5. So, what is like a total air you take, right? You see, your total air is this much gram, this mole, this much mole, so you can find it out very easily what much is that. And this fuel is there. So this is called this stoichiometric ratio for the gasoline, right? So air fuel ratio 14.5 to maintain. So therefore your full combustion that is taking place. So if it is a air is lesser, then it is called a rich mixture. If it is a more air, then it is called the lean mixture. Okay. So first thing is that your hydrocarbon and the carbon monoxide emission. If it is a rich mixture, means that your fuel is higher, so which will encourage more production of CO, right? And unburned AC means there is not enough oxygen for the complete combustion. So that will come out, of course, more hydrocarbon that will come out there. And if so, therefore, if you make a leaner mixture, then that will, of course, leads to this CO and H reduce in the CO and H emission unless the mixture becomes so lean that misfire, right? The fuel is so less that there is actually it is not enough to take this correction. Okay. Now what happens that if you are making leaner NOx emission, so that is a very difficult part, this NOx emission, because if there is a rich mixture also, then there is a lack of oxygen, right? So therefore, which lowers the combustion temperature, reduce. If it is rich mixture, then it is a reduce the NOx emission. However, beyond a certain point, these mixtures may have so much excess air that the dilution this lowers flame temperature and also reduces your NOx production. But what happens that here you can see that, right? So if you want to make your this fuel consumption very less, your CO emission less means that you see that you are keeping, this is your stoichiometric ratio, so you are keeping next to that. However, that part actually, this your NOx emission, that becomes high because you see that you are keeping a mixture or leaner. That time actually your NOx emission is lesser, but you don't want to keep that. Stoichiometry you are keeping up, but there the combustion temperature is the most efficient, it is very high, and your NOx emission is the highest. So this is actually problem where you can make it your engines very efficient and so that your that's why they say that engine when it is old, please discard it, right? It cannot maintain this part when it is becoming old. Okay. So however, at that time your this emission, NOx emission becomes the higher. Okay. So there are like this few techniques there actually that you can please change that. So it is not, this is different. This is the positive crankcase ventilation. This some pollutants, this find their way around the piston during the power and compression flow into the crank. So this is for the blower, right? And it can be recycled back into the engine intake system to give it a second chance at being burned and released as the exhaust system. Okay. So, and that is your increasing your efficiency, and crankcase ventilator will adjust the rate of removal of blowby gases to match the changing air intake requirements of the engine, making sure that the desired air-fuel ratio is not upset by this added gas, right? Okay, so which is the first part of this analysis, making the fuel efficiency or increasing that. Right, this is, I am not discussing that, you can actually please go through this thing, this part. These two-stroke engines are there, and at the diesel engine also, I think diesel engines have these two-stroke engines. The diesel engines is that like that, it becomes, it don't need spark plug, it becomes like it's so hot actually that it can combust by itself, right? So this combustion takes place, right? So these characteristics things are only this informative, this portion is there, so you can go through that, right? And two-stroke engines are there, is two-cycle engine, is more power for its size than a conventional four-stroke engines, because there is no moving valves are there, right? Yeah. So you can understand that there is no valves are there, but this one is actually used in some this lawnmower, etc. That these things are used in. Yeah. So here is the one that what is the your way of automobile these emission controls. Right, so this occurs as a post-combustion control, which is one of these ways is three-way catalytic converter. Right, where you see most of this control of this automobile emission occurs in the exhaust system. So therefore this exhaust manifold, this completely this exhaust manifold system is there. This tailpipe is there. So here actually we employed a catalytic converter. If you remember that NOx emissions when we discussed using your stationary part there. There also these things are actually employed there. So catalytic, this flue, this exhaust gas, what you do, you actually run it through the catalytic bed, right? And catalytic bed is for the three-way because it can take care of this CO, X2, NOx. So there only this NOx part was there. And for that, you see that this oxidized hydrocarbon, carbon monoxide, carbon dioxide, this turns into carbon dioxide, and NOx becomes N2. The same, these equations are there. So you have to monitor that this part, exhaust sensor is there. So that full thing actually takes that. This electronic feedback signals are there, and it can control this this part there. And catalytic converter, you have to this. Oxygen of course is there, you have to make it really hot there and pass it through this catalytic converter there, and these are the reactions that can take place on this part. Okay. So I haven't let us stop today's class here. We will be next class actually let us discuss this alternative fuel, right? I will make a few slides there because let us not going to be discussed very much in details, but just to become aware of that, right? And after your this semester break or maybe next class only, we will start that another important part, that is the meteorological effect, right? Meteorological effect means that this pollutant dispersion, the role of your atmosphere or the weather on the pollutant dispersion, which is more important part that we will discuss. Aryan, Abhirashi, Diwan, Deepak Yadav, Kirti Singh, Archie Singh, Saloni.
मेरे अटेंडेंस नहीं हो वाला आरिफ देवी.
You are Aryan Singh, okay. I didn't hear that. Naina, Bharti, Prabhakar, Rachi, Anushka, Dipanjan,